This is the third case for undetermined coefficients in the nice one. Sometimes you have to modify it. But here we have method of undetermined coefficients, y double prime minus y prime minus 12y equals 13 sine of 2x. So most of the time, when people try this out, me included, is I thought, okay, well, it's got sine 2x there. Why don't I just guess y particular of x equals an unknown constant a times sine of 2x. Right, because I have a sine of 2x here, I want to end up with a sine of 2x, why don't I just guess sine 2x? And that won't work, and let's just see why. So we have y particular prime of x. We'll take the derivative, 2 will pop out, sine will turn into cosine, and we get 2a cosine of 2x. Take another derivative, we have y particular double prime of x equals negative 4a sine of 2x. The negative from derivative of cosine, and then another 2 pops out from the chain rule. Now if we add these together, if we do y particular double prime minus y particular prime minus 12 y particular, we want that to equal, this 13 sine of 2x. We plug them in, we're going to end up with negative 4a sine 2x. Then we have a minus 2a cosine of 2x for the y minus y particular prime term. Then we have a minus 12a sine of 2x. And now we've got a problem. We've got 13 times sine of 2x on the right-hand side, and we have a negative 4a sine 2x, and we have a minus 12a sine 2x, so in total that's minus 8a sine 2x. But we also have this minus 2a cosine of 2x. And over here, it's really plus 13 sine of 2x plus 0 cosine of 2x. You're going to get the terms to agree. And so we can pick the a to solve for the 13. It would be, what would that be, negative 13 over 8. But that will mess up this cosine term because we have to get exactly 0 cosines. Then if we want 0 cosines, we pick a equals 0, then we get 0 for the whole thing. And so we actually can't get this to work. It just won't happen. So instead, we need to modify the guess a little. We have to guess for both a sine 2x plus b cosine 2x. So this guess didn't work, so I'm going to cross that out. And we're going to modify this guess slightly. We're going to guess instead a sine 2x plus b cosine of 2x. And then we'll get sines and cosines in every single term. We'll have an a and a b to mess with to get the right-hand side we want, and hopefully it'll work. So if I add b cosine 2x, this will be a minus 2b sine 2x, and then I'll have a minus 4b cosine 2x here. Now if I add those together, okay, well I have, let's see, so y particular double prime, so negative 4a sine of 2x minus 4b cosine of 2x, and then I've got my minus, so I'm subtracting y particular. I think I'm going to run out of room here. Well, let's see, I'm going to subtract, so I get not minus 2a cosine 2x, I get minus 2a cosine of 2x, and I have a minus minus 2b, so plus 2b sine 2x. I'm going to have to go down here. So yeah, then I have to have a minus 12 y particular. Okay, so that's going to be minus 12a sine 2x. And I've got a minus 12b cosine 2x. And then all has to equal 13 sine 2x. Okay, well if I start grouping terms together, I have to get, let's see, I have a negative 4a times sine. I have a positive 2b, so let me just write that out. I've got negative 4a times sine. I have a plus 2b times sine. And then I have a minus 12a times sine. sine of 2x, but that's also added to all the cosine terms. So I've got let's see, negative 4b cosine 2x. Then I've got a minus 2a cosine 2x. And then I've got a minus 12b cosine 2x. And again, that all has to equal, what is it here? 13 sine 2x. And really, plus 0 cosine 2x. All right, so I've got negative 4 minus 12, so that's minus 16a plus 2b. That has times sine 2x has to equal 13 sine 2x, so that has to equal 13. I also have, let's see here, I've got a cosine, negative 4 minus 16, that'll be minus 12, that'll be negative 16b. And then I have a minus 2a, has to equal 0. Well, all right, so if I take, let's see, which is the easiest one here? If I take 8 of the first equation, and I add it to the second, that sounds hard. I don't want to multiply with 13. If I take negative 8 times the second equation, and I add it to the first, so negative 2 times negative 8, that's going to be positive 16. That'll cancel out with the negative 16a. Then I have negative 8 times negative 16. That's going to be 128, I'm pretty sure. I'm going to add that to 2b, so it's 130. b equals 13, I'm pretty sure. Oh, all right, so let me emphasize that kind of looks like a b. Okay, so then if I divide, then b is 1/10. And I did that from my notes, so you do have to go through and subtract these. Right, 8 times the first, 8 times the negative 8 times the second, I added it to the first to cancel out the a's. But here I've got b is 1/10, and then if I go in, I put in 1/10 for here, so that would be, let's see, negative 16 times 1/10 minus 2a equals 0. If you end up solving for that, a ends up being, let's see, I think negative 4/5, according to my notes at least. And so the particular solution that works to solve for the right-hand side is actually, let's see, a was on the sine, so that's negative 4/5 sine of 2x plus 1/10 cosine of 2x. This one is a little worse because all the terms are mixed together. So for polynomials, you kind of get one term at a time. For exponentials, there's just one unknown coefficient. When you have sines and cosines, you end up with the terms mixing. You have to do a little bit of linear algebra in order to solve for the undetermined coefficients.